equations. I'm just going to do it like that. So let's just look at it just number-wise, and then we'll look at the official definition of it, which is not always the definition that we use. Then we'll do a couple simple examples, and then I've got 4 more Algebra 2 examples. So if I'm taking the absolute value of a positive 3, if I take the absolute value of 0, and if I take the absolute value of a negative number, we'll do negative 4. Okay. What's the absolute value of positive 3? Positive 3. What's the absolute value of 0? And what's the absolute value of negative 4? Positive 4. And we'll write the signs. I'd encourage you to do that. Absolute value, we've always said, is the distance from 0, which, if you remember, distance is always positive, then in that case, that's why it will come out positive. Now look at the mathematical definition. It says if x is greater than or equal to 0, it's talking about the number that's in here, comma, then the absolute value of x is equal to x. Okay, I think you would agree with that. If x is positive, right here, its absolute value of x is x. If x is 0, absolute value of x is x. Now look how it's defined for negatives. If x is less than 0, then the absolute value x is, and I'm just going to write it. I'm not going to say it. And I think it'll make sense because we've always said absolute value can't be negative. But look, when you look at it in the whole problem, it says if x is less than 0, then the absolute value of x is, and if you'll translate this, the opposite of x. So if x is negative, its absolute value is its opposite. Or if you say negative 1 times your x, if you translate it like that, well, negative 1 times negative 4 is positive 4. So this definition is no different than what we've always said. If it's positive, positive. If it's 0, 0. If it's negative, it's its opposite. And that's what that official definition says. Now, if I have, this is more the Algebra 1 review. If I have the absolute value of x equals 5, what can x equal? Be 5, or x could be negative 5. Write it like that for me. The key word here is or. You need to remember that. It can't be both of them at the same time. And then another notation that we use a lot of times is we say x equals positive or negative 5. And we're saying or. We say it really quickly, but we write it like that. What about the absolute value of x is equal to 0? Put on here, it has 2 solutions. Okay, and then absolute value of x equals 0. What's the only thing x can be? 0, 1 solution. And then what about the absolute value of x is equal to a negative number? We'll put negative 7 there. Okay, what number will fit in here whose absolute value is negative 7? Well, it can only be 7 or negative 7. Is the absolute value of 7 negative 7? No. Positive numbers, positive. Absolute negative 7 is its opposite, which would be positive 7. So it's no solution. Start with 1. Let's try the absolute value of 2x plus 1 is equal to 5. So it leads off very similar to this one. This in Algebra 1, I would always, I had a cutout, and it would leave you 2 blanks, and it would say, think about what can go in here. If you picture this as your unknown, because we're actually saying the absolute value of what is equal to 5. Well, then what's in here, and I always tell students too, you can't do anything with an absolute value bar in an equation. You've got to get that bar off of there. So if we take what's inside, then we can say 2x plus 1 can equal 5, very similar to this one up here, or 2x plus 1 can equal to negative 5. Now think about it. If I hide what's in my absolute value bars, I'll cover it up like that, then I know what can go in here. That can either be 5 or that can be negative 5, just like this one up here. Well, let's see what works. Let's solve this equation. And I get 2x equals 4. x equals 2, and then subtract 1, and we'll check both of them. Oh, 2x equals -6, x equals -3. Now I went on and circled them. Let's see what happens. If I put 2 in, I get 2 times 2 is 4, plus 1 is 5, and the absolute value of 5 is 5, so that one checks. And -3 times 2 is -6, plus 1 is -5, equals 5. When your absolute value by itself, now that's going to be important. If the absolute value bars are by itself, like this, absolute value, nothing attached to the bars, then you're going to always have two answers if it's equal to a positive number. Right here. Here's a great example of it. When you get through with it, if you've got absolute value bars by itself, you're going to have two answers, because you can go the positive route, you can go the negative route. Number 2. -8, absolute value bar, 3x minus 7, absolute value bar, equals -24. Get absolute value by itself first, and I also will say you cannot distribute with absolute value, and I put absolute value bars last year. You'll get one answer right and one answer wrong. What happens if you take this -8 and try to distribute it? It throws it into a totally different, like one of the answers will work and one of them won't, simply because of the way it's set up. So the main thing is get your absolute values by itself. I need this thing right here. I used to make Algebra 1, take a colored pencil or a highlighter, and I'd make them highlight that. And I'd say, we need to get rid of whatever's attached to it. That's attached by multiplication, so we need to get rid of that by division. And we get absolute value of 3x minus 7 is equal to +3. Now at that point, see, looking at it, it looked like there wasn't going to be any answers, no solutions, because you had looked like absolute value was equal to negative. But once we got the absolute value bars by itself, you can look up here and make your decision. Absolute value equals a positive number, you're going to have two solutions. And I think that's what we went with in the classwork. Now I need you to show this work. I need 3x minus 7 equals 3, or 3x minus 7 equals -3. What's in here can be 3, or what's in here can be -3. Add 7, you get 3x equals 10, x equals 10/3, 7, you get 3x equals 4, divide by 3, x equals 4/3. The thing I've seen from last year was my dear Aunt Sally sure got upset because getting the absolute value bars by themselves involve order of operation. Okay. You got a -2 that's added to the absolute value bar. I've got to get this by itself. So we're going to add 2, and I get absolute value bar 3x plus 2 is equal to 13. Get your absolute value bars by themselves. 3x plus 2 equals 13, or 3x plus 2 equals -13. Show that work. 3x equals 11. X equals 11/3. 3x equals -15, x equals -5. When you get to right here is where you decide. If I had absolute value equals to 0, then I would know that 3x plus 2 could only equal 0, one answer. If 3x plus 2 was equal to negative something, no solutions, automatically, without having to do a lot of work. 3 plus 9, absolute value bars, -3 minus 5n, absolute value bar closed, equals 75. Now, poor my dear Aunt Sally, Now, I've seen students take this and want to add the 9 and 3, and that's automatic -4 and should be a -5. Because order of operation, look at, here's your unknown. This is what we're trying to get by itself. That's your x. You're trying to get that by itself. Well, you know, back when we would do 3 plus 9x equals 75 in pre-algebra and in Algebra 1, to get x by itself, that's your big unknown, you'd have to subtract your 3 first. Never, ever could we add those together. Those are not like terms. These are not like terms. Get 9 absolute value of -3 minus 5n is equal to 72. Now the 9's attached to the unknown by multiplication. Absolute value of -3 minus 5n equals 8. Now, you cannot solve that equation without getting the absolute value bars off of it. You've got to get the absolute value bars off to write your two equations. So what's inside, and I really look for notation. What's inside can be 8. It's exactly like this. That's what it's saying. What can go inside that absolute value bars? What's in here can be 8, or what's in here can be -8. Add 3. -5n equals 11. N equals -11 over 5. 3. -5n equals -5. N equals +1.